Nowadays, a lot of musical concerts are being hosted in sports arenas and grandstands. The reason being is that these sports arenas have a large capacity for hosting a lot of crowd. Unfortunately, these sports arenas and grandstands are not designed to accommodate this type of vibrations because they were designed back in the days in the 90s or 80s. Here in Curtains, we have the expertise and the tools to do such a complex and dynamic analysis of these structures. According to the Institute of Structural Engineers guidance, we have 4 types of crowd action on structures, and this is related to the livelihood of the crowd and also the song's frequencies. So we have scenario 1, where everyone is sitting down, maybe listening to Frank Sinatra. They are almost about to sleep. They're not causing a lot of dynamic action to the structure. Scenario 2 is more lively people. They are attending some sport event, but they are not causing a lot of dynamic action to the structure. Now scenario 3 is more severe actually, where we have lively people. They are potentially excited if they were singing a good song, and maybe someone is scoring a goal, or maybe attending a musical concert for a bit more lively performer. Scenario 4 is the worst for the structure, where you have very lively people, young crowd of doing a lot of vibration, jumping together, bobbing together, and reacting very well to the musical concert or any sport event. And based on these 4 scenarios, we have 2 methods to analyze our structures. So the simplified method is find the mode frequencies, the natural frequencies of the building or the structure, and if it's above 6 Hz, then this is fine, but it's very difficult to get the frequency of the structure above 6 Hz, because this would require an economical design for this structure. Most of the structures existing now, they have a frequency of about 3.5 Hz, which require going through the complex method of analysis, which is applying the actual load as periodic loads to the structure, and then assess the maximum response of the building, and then compare that with the acceptable limits from previous experience. What we can do is to get the loads depending on the song frequency, and also depending on the type of scenario we are analyzing. So for scenario 3 and 4, the loads will be much higher than scenario 2, and for scenario 4, the load will be almost twice the load for scenario 3. And we have also to apply these loads periodically, because they are a dynamic load applied to the structure. It's very important that we have to realize that there is an interaction between the human and the structure. And if we don't take the human structure interaction, the potential of having misleading results is very high. And what we can do is representing each person on the structure by a dashboard spring mass system, which will be applied the load to, and then this load will be transferred through the system to the structure. This additional system here will add to the stiffness and the damping of structure, and will change the results of the response very much. An example we've done for a Premier League club, they were asking if they can host concerts during the off-season period. And what we've done, we started with the 2D analysis of the stand to realize which mode will be the one that could be excited by the crowd. And then we found that the 3rd mode is the one that could be excited by the crowd, but it has a frequency which is much less than 6. So it has a frequency of about 3.5 Hz. And that meant that we have to go through the complex dynamic analysis of the structure. We had applied the loads as we described before, and then we realized that we cannot use the full stand for hosting the concerts. We have to net off about 2 to 3 rows to get it to the acceptable limit of vibration. And also because at scenario 3 and 4, the people are very lively and they will be applying a lot of dynamic load to structure, there is a possibility of having fatigue fracture. So we had to go through the fatigue analysis of the building and check how many concerts the club can host before they have problem with fatigue to the structure. To strengthen our results, what we've done is that we developed our 2D model to 3D model, which is very realistic model. And what we've done, we modeled the precast panels and all the seating areas and the horizontal bracing of the roof. And in this way, we have very realistic representation of the stand. And then we did compare our 3D results with our 2D model, and they were not very far off the 2D analysis. Still, we have the third model, which can be excited by the crowd, and it was about 3 Hertz. So we had to apply dynamic load as periodic load to each person, which was about 4,000 person attending on this piece of the structure. Also, we had to go and do some site survey and check the capacity of the existing structure, and we had to check what is the actual capacity of the design structure so we can decide how many rows we can utilize during the concert and what type of dynamic load the structure can accommodate. And based on this analysis, we recommended that about 5 rows can be netted off so the structure can act safely and the crowd can enjoy the musical concert. Thank you.